Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Alhamdulillah rabbil alamin. Wassalamu ala sayyidina Muhammadin wa ala alihi wasahbihi ajmain. Rabbi shrah li sadri wa yassir li amri wa uqdatan min lisani yafqahu qawli. Rabbi zidni ilma warzuqna fahma. Allahumma faqihna fid din wa ta'wil. Alright, welcome back to Flick class. Inshallah today we will continue a chapter on our next chapter, which is chapter 2. We'll be looking at the pressure and fluid static. Inshallah today we'll be looking at pressure and fluid static. And as for today, we'll be looking at pressure at point, pressure variation in a static fluid, and manometric pressure. Okay. So we have 3 points we'll be looking at today. Alright. So what is chapter 2? Chapter 2 is about fluid static. Fluid static. Okay, first of all, you need to understand what is pressure. Okay, pressure. What is pressure? Pressure is defined as a normal force exerted by a fluid per unit area. We speak of pressure only when we deal with a gas or a liquid. Okay, alright. So what is pressure? For example, we have a plate, and then you apply a normal force to the plate, and then per unit area, the force per unit area, and then this area becomes pressure. This area becomes pressure. So what is pressure? If you define pressure, pressure is defined as force per unit area. So the unit is in kilo Pascal or Pascal. Okay. Cool. So that is pressure. Alright, so pressure, the unit, as I said before, is in Pascal, or you can write it as Newton per meter square. Okay. For example, the normal stress. Okay, normal stress we had learned before in chapter 1. Normal stress also called pressure. Okay, the pressure, if you have the weight, if the weight is higher, and then the pressure exerted on the area is also higher. For example, we have we have an area. Okay, we have a plate here, and then we have a cinder bar, and then we have another plate, okay, under the cinder bar. Okay, if I put a weight here about 10 kilogram, okay, 10 kilogram, so the force will be, just need to type 10, so the force will be mg lah. Find the force mg weight. The force in the area will become the force you will exert and force to the area. Okay, if we have the same plate with the same handlebar, and then with the same foot area, with the same foot area. Okay, foot area is the same, and but I put a weight around 30 kilogram. Okay, so since the weight is higher, the weight at 1 and 2. Okay, so since the weight at 2 is higher than at weight at 1, so the pressure exerted at the area below, the plate below, is higher at 0.2 lah. 0.2, the higher this pressure. Okay, so pressure in this case is, okay, we have a connection pressure with the weight lah. Okay, the higher the weight, the higher the pressure. Okay, if you have if the area where we apply the pressure is the same lah. Okay, that is pressure. Okay, pressure is divided into 3, which is absolute pressure, gauge pressure, and vacuum pressure. Okay, how we define gauge pressure, absolute pressure, and vacuum pressure? Okay, here we write it. The slide is defined as the actual pressure at a given position is measured relative to absolute vacuum. So, do you understand what this word said? Okay, gauge pressure. The difference between the absolute pressure and the local swing pressure. Most pressure measuring devices are calibrated to reach 0 atmosphere, and so they indicate the gauge pressure, vacuum pressure, pressure below the atmospheric pressure. So do you understand any words that have been given in this slide? I don't think you understand. So let's look at what's gauge pressure, absolute pressure, and vacuum pressure. Okay. So first of all, we look at, for example, we have a line of pressure ATM. Okay, it is a pressure ATM. Okay, if you measure anything, we start measuring from zero. Okay, when we start measuring from zero, so if you measure a pressure starting from zero until you get it to the PATM, and then you got PATM. This pressure is PATM. Okay, and then if the pressure is gone above the PATM, okay, this pressure become gauge pressure. Okay, and then if you measure the gauge, if you measuring the pressure from starting from PATM and above the PATM, you will get gauge pressure. If you measuring a pressure starting from zero until above the PATM, and then we got absolute pressure. Absolute pressure. Okay, and then if you measuring a pressure below, starting from below the PATM, this we call it the vacuum pressure. And if you measure the pressure starting from zero until the vacuum pressure, and we got the absolute pressure. Okay, what is P absolute? P absolute is pressure measuring from zero. Okay, measuring from zero. Okay, usually the gauge pressure when you pump your tire at the local pump station, okay, that is the gauge pressure. You are using the gauge pressure to pump your tire, not the absolute pressure. If you want to get the absolute pressure, for example, you pump it until 101 kilopascal or 120 kilopascal. So this is the gauge pressure you got from the pump station. If you want to find the absolute pressure, you need to plus with the local atmospheric pressure, which is usually 101 kilopascal lah. This is PATM lah, PATM. Or we have a 1 bar. Alright. So I hope you understand what is different between this gauge pressure, absolute pressure, and vacuum pressure. Okay. Alright. So if you want to find the gauge pressure, okay, here we have gauge pressure equal to PABS minus PATM. If you want to find the vacuum pressure, PATM minus PABS. So here you want to find the gauge pressure, so we need to subtract P absolute from PATM, and then you find the gauge pressure. So kat sini the gauge pressure equal to PABS, ni ABS, PABS minus PATM. And here, if you want to find the gauge pressure, so you can do the vacuum pressure, P vacuum, you need to subtract PATM minus PABS. Alright, hope you understand. So next we'll be looking at an example 1. Okay, we have a vacuum gauge connected to a chamber reading 40 kilopascal. At location where atmospheric pressure is 100 kilopascal, determine the absolute pressure in this chamber. It's a very easy equation. Okay, we have a chamber. We have a chamber. Alright, this is a chamber. In this chamber, we have 40 kilopascal, and outside the chamber, the PATM is 100 kilopascal. Okay, the question is they want you to find the absolute pressure in the chamber. Okay, what we got here is the gauge pressure in the chamber. The gauge pressure, we know that gauge pressure is P gauge equal to PABS, sorry, PABS plus, sorry, P plus minus PATM. Okay, so they want you to find the PABS. So the PABS is equal to P gauge plus PATM. So in this case, the PABS will be 140 kilopascal. Okay, that's the first example lah. We have the example. Oh, sorry, this here the question is about a vacuum gauge pressure. So the vacuum gauge pressure. So we need to use the vacuum equation. So the vacuum equation is let's turn it back. Okay, let's go back a bit. Okay, we have a vacuum equal to PATM minus PABS. So PABS equal to here to here, here to here. So PATM minus P vacuum, and we got 60 kilopascal. Here is vacuum pressure. Vacuum pressure. Alright. Okay, now we'll be looking at the pressure at point. So what is pressure at point? The main thing is pressure at point that you need to know is pressure at any point in the fluid is the same in all direction. Okay, very simple. What you have to say is you have a cup of glass. Okay, in the glass we have water, and then we have point 1, point 2, and point 3. At this point, pressure from any direction at this point is the same at the point, very small point. Okay. Same here, pressure at any direction at this point is the same. Same here, pressure at any point at this direction is the same. Okay, it's P1, P1, for example, is P1, P1. Everything is P1. We get P2, we get here P2, P2, also P2. Here is P3, 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 and P3. Okay, any point in this direction is in any direction at a point, the pressure is the same. Okay, pressure at a point is the same in any direction. Remember that is the pressure at a point. Okay, next we'll be looking at the variation of pressure with depth. Okay, what does mean by the variation of pressure with depth? Okay, so to put it simply, we say here it will come as no surprise to you that the pressure in a fluid that rests does not change the horizontal direction. Okay, we know that pressure at horizontal is the same as direction but different in vertical direction. Okay, what I say here is, here for example we have a pool. Okay, inside the pool we have water. Pool, we have water. Okay, pressure at any point in this horizontal line, alright, is the same. Everywhere is P1, 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 and P1. And we have another horizontal line. And then the pressure here is P2, 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 P2. And for example, we have another one, P3, 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 and we have P3, P3, and P3. Okay. Pressure at any point in the same horizontal line is the same, but different in vertical line. Okay, they're the same, but different in vertical line. Different. Okay. The deeper you go in the fluid, the higher the pressure. Pressure become higher if you go deeper. So P1 is smaller than P2 is smaller than P3. Okay, the pressure is high at P3 compared to P2 and P1. The pressure at P2 is higher than P1. Okay, I hope you understand. What I mean by the pressure become higher if you go deeper. You can experience it as you swim. If you swim in water, the deeper you go in the water, and the higher the pressure you will feel. Right? Alright, that's the variation of pressure with depth. Okay, the deeper you go, the higher the pressure. Alright, okay, next. Okay, this example. We have a free body. It's okay not to look at this free body diagram. Okay, here we have a P equal to P ATM plus rho GH. Okay, what is P here? Okay, what is P here? What actually is P here? P ATM plus rho GH. What does P plus with rho GH? P ATM plus rho GH. Rho GH is P gauge. Okay, rho GH is P gauge. Okay, when we P gauge plus P ATM, we got P absolute. So this is P absolute. P absolute equal to P ATM plus rho GH. Okay, the pressure in water, P. For example, pressure in water is equal to rho GH. In this one, H1. Here we have H1. And we have here another H2. And we have here is H3. For example, H3. So P2 equal to rho GH3. Rho is the same because it's the same fluid. Okay. P3 equal to rho GH3. Okay. This pressure we call it gauge pressure. Gauge pressure. Okay, this is gauge pressure. Alright. Okay, so it's okay not to look at this. Okay, and then another one. Okay, alright. Here they're giving you example of a room. A room filled with air and a cup filled with water. Okay, what difference with a room? For example, we have a room. Here we have a room. A room filled with air and a glass filled with water. Okay, what's different? The pressure. Okay. If the room is filled with air, at any location, the pressure in the room is the same. P1, 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 P1. Okay, we know this because if you in your room, you are standing in your room, anywhere in your room, you feel the same pressure. So that is the proof. That's the pressure at any point, at any elevation, at any height in a room that filled with air is the same. Right? But not for liquid. If liquid, the pressure at the horizontal line only that is the same. If you go deeper, for example this water, the pressure will become higher. Yeah, the pressure will become higher if you go deeper. Alright, In a room that we fill with air only, this is the case for air. The pressure at any point in that room is the same, right? Anywhere. I hope you understand. If you have any question, you can ask me later. Alright, so this is we have a picture here. Okay, here we have A, B, C, D, E, F, G. A, B, C, D, F, G is at the same horizontal line. So they are the same fluid. Okay, since they are the same fluid and at the same horizontal line, A, B, C, D, E, F, G is the same. Pressure, the pressure at A, B, C, D, E, F, G is the same. But yeah, I and H is also at the same horizontal line, but they are not the same fluid. At I, the fluid is water. At H, the fluid is mercury. So mercury is heavier than water. So the pressure at H is higher than I, although they are the same horizontal line. But because they are different fluid, so even though they are at the same horizontal line, the pressure is different. Alright. Okay, this pressure we are talking about pressure. So the pressure is we are talking about is come from the Pascal law. Okay, the pressure applied to a confined fluid increase the pressure throughout the same amount. Okay, the area ratio A2 over A1 is called the ideal mechanical advantage of fluid hydraulic. Okay, alright. So here is the Pascal law, and this example for Pascal law for hydraulic lift. Okay, we have here hydraulic lift. Okay, the pressure at point 1 here is actually the same as the pressure at point 2. Okay, alright. But we apply the the pressure at the point 1 is the same as at point 2 lah. Okay, apply the force. Okay, we apply force. We have a higher force lah. That's in this case. Okay. Okay, we have applied small force and we got a higher force. Alright. Now we'll be looking at a pressure measuring device. Okay, this is the barometer. Okay, this barometer you had learned in the physics. Okay, barometer contain a mercury in the cup, and then we have a cylinder. Inilah a cylinder. Okay. Okay, the pressure in a fluid, you must remember if you measuring pressure in fluid, P equal to rho G H. This is the equation I'm using. Okay, this pressure we call it gauge pressure. Gauge pressure. Okay, must remember it. Okay, alright. This is barometer. Barometer usually used to measure atmospheric pressure. Okay. Alright. Next, we'll be looking at the. Alright. This is an example. Okay, this is an example about how to measure pressure with a barometer. Okay, determine the atmospheric pressure at location where the barometer reading is 740 milligram HD and the gravitational acceleration is 9.805 meter per second square. Assume the temperature of mercury to be 10 degrees Celsius, at which intensity is 13,570 kilogram over meter cubic. Okay. So to calculate the pressure, you just need to use the equation PATM equal to rho GH. Just insert the value inside here, but you need to remember always change your unit to SI unit. And here we have a SI unit 740 mm. So you need to change it into meter. You need to change it into meter. So the pressure we got is 13 kilogram, 570 kilogram per meter cubic times 9.805 meter over second square times 0.70 meter, and then we got 98.5 kilo Pascal. This is how you measure pressure in a barometer. Okay, another one, the equipment that we use to measure the pressure is the manometer. Okay, manometer, we have many type of manometer. Okay, the one we're looking at here is the basic manometer. Okay, the basic manometer is a U type manometer. Why we call it U? because the shape here, tube here, is U. So that's why we call it U. The same here is U, since the tube is U, so we call it U tube type manometer. Okay, U tube type manometer. And here we also have the same manometer. Also, we have a fluid, different fluid in the same container. This also we call it manometer. Okay, simple manometer. Okay, how we measure fluid pressure at a point in manometer. For example, we have here a very simple manometer where we have a stack of fluid layer. Okay, for example, we have here a simple manometer. Manometer here we have a container. Inside the container we have different fluid layer. For example, we have here mercury, and we have here water, and we have here an oil. Alright. So for example, if I want to find the pressure at point 1, how do I find the pressure at point 1? So using the concept of manometer, you need to remember if the pressure is going down, and then it's plus. If you are going, okay, if you are going up, the arrow is going up, and then it's minus. What I mean by arrow, so for example, you are measuring the pressure at point 1. Okay, for example, this is point 2. So measure point 1 to starting, your starting line start from point 1, so point 1 until the layer of oil H1. Okay, and then you start again, we go from the layer H1 and to the layer H2 until we get layer H3. We know that if you want to measure the pressure inside a liquid, we need to use the equation of rho g H. Yeah. So for example, here we have PATM. PATM. So P1 is equal to PATM lah, since PATM. So P1 plus rho GH1, this rho oil, so oil. So we have water plus rho water GH2, and then plus rho, sorry, this rho mercury GH3 equal to P2 here. It's P2. So I need to change it to 2. So P2. Yeah, P2 here. Why plus? Because the arrow is moving downward. Okay, moving downward. Okay, moving downward, and become plus. But if you're measuring the pressure starting from point 2, for example, we have point 2. Okay, it's okay to measure, but you go upward, so minus rho mercury GH3. Then you go up again, minus rho water GH2, and then minus rho oil GH1 equal to here P1. Okay, it's actually the same lah. It depends on your starting line. Your starting line from the upper line, and then if you go downward, it become plus. If your starting line is in the bottom, and you go upward, and then it become minus. Alright. I hope you understand what I'm saying. Alright, that is the simple stack layer of fluid of manometer, and then we'll be looking at the very simple U tube manometer. For example, we have a container. It is U tube manometer. For example, we have a container here. Okay, it's connected to a U tube manometer. Okay, in this manometer we have water. For example, we have water. Okay, the water in the tube is called it manometric fluid. In this case, water. Okay, the height here is, for example, we have H, and inside this container is air. Okay, you must remember any pressure at any point in this container is the same because here we have air. So here is the same lah. Okay, so when we want to measure the pressure at point 1 here, so how you start measuring? So since the layer end here, the layer of water end here, up here, so your arrow whether can be upside go up or go down. Okay, here we have PATM. PATM. So if I start from P1 and then the pressure will be P1, since go up is minus. So what is the pressure? The pressure is here. We measure it by using rho GH, right? So rho GH equal to, we got here PATM. So if you measuring from the upper layer, you go down. Okay, you go down. Okay, you go down. So it become plus. Sorry. Sorry. Okay. It become plus. So you be measuring from PATM. So PATM plus rho GH equal to P1. Okay, this is the, so the equation is differ if from your starting line, where you choose your starting line. Okay, that is the example for the basic YouTube manometer. Okay, if any question, please ask me in this class. Okay, alright. This okay. So this the YouTube manometer. Okay, the YouTube manometer. Okay. Alright. So for example, we have another one, the same YouTube manometer. We have another one YouTube manometer, but this time inside this tube. Okay. We have here is mercury. So this time the manometric fluid, manometric fluid is mercury. Okay. So inside the container we have water. So we want to measure the pressure at point here, point 1. Okay, does point 1 here the same at point 1 here? They are not the same. Why they are not the same? Because this time we have water. The deeper you go, the higher the pressure. So here we have point 2 is actually PATM. So if you want to measure the pressure at point 1, for example, I start from point 1, I go down, and then I go up. Okay, so P1 here, P1 here, since I go down, so plus rho of water, since this inside is here is water, GH. So for example, here is H1. Okay, and from here to here is H2. Okay, so H1, and then we go up, the minus rho mercury GH2 equal to PATM. Okay, your starting line, if your starting line is okay, if your starting line is from up here, and then you go down, okay, go down, and then you go up. Okay, so equation will become PATM plus rho mercury GH2 minus rho water GH1 equal to P1. Okay, if you go up, and then it become minus. If you go down, it become plus, the arrow that you write. Okay, from where to where? From the here, the line of the fluid. Okay, here is line fluid of mercury, and here is line of fluid of water. Right? Alright, that's YouTube manometer, and then we have another one is incline tube manometer. It's the same concept. Okay, but this time, since it's incline, we have another one, incline manometer. Here we have a tube. Okay, we have a tube, and then connected to a incline tube manometer. Alright, sorry. Okay, this one, tube manometer. For example, here we have water. We have the water, and then here we have connected to a You have here mercury. So this mercury is your manometric fluid. Okay. So the same, if you want to measure the pressure, for example at point 1 here, we have air here. Okay. Point 1 to point 2. So you go here, and then you go up. Okay, you go up. So the same. So P1, you go down. So plus what? Rho water. Rho water GH1, for example here is H1, and you have here the decline is H2. H2 okay, right. Usually they have a degree about 30 degree or less. Okay, right. So we go up, so become minus rho or rho mercury G. Alright, see H is whether you measure and pressure, make sure that the height is always 90 degree. Okay, if you have H2 right here, you have the degree here, so you need to find the H here. Okay, H here is sine. We have sine 30 lah. We have H2 sine 30. Okay, so H2 sine 30. Alright, if H2 sine 30 equal to P2. Okay, here 2 here. We have P2. We have P2 here. So this P2. Okay, this P1. Okay, hope you understand this incline manometer. The height is always 90 degree. Okay, below the surface. Okay, if you have a surface of water here, you cannot measure the height like this, H1. You must measure the height always like this, 90 degree from the water surface. Okay, must and always H must always perpendicular to the water surface here. Alright, and then that is the incline tube manometer, and then this is the we call it example example 3. So I need you to okay, this is example 3. I will be looking at this later in the tutorial. Okay, so as for this class, okay, we end in here first, and then I will continue our class in the next subtopic, which is okay, right, which is the direction to fluid static. Okay, the pressure in a fluid static. Alright, thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.